Hi and welcome to this video in which we like to think of statistical hypothesis testing as the data analysis stage of a comparative experiment in which the researcher is interested, for example, in comparing the mean of a population to a specified value, e.g. mean pull strength. If you discover our channel for the very first time, don't hesitate to subscribe and activate the notification bell so you don't miss any of the next videos. A like and sharing of this video will also make us happy and allow many other people to discover it. The general goal of a hypothesis test is to rule out chance, sampling error, as a plausible explanation for the results from a research study. Hypothesis testing is a technique to help determine whether a specific treatment has an effect on the individuals in a population. The hypothesis test is used to evaluate the results from a research study in which 1. A sample is selected from the population. 2. The treatment is administered to the sample. 3. After treatment, the individuals in the sample are measured. In this graph, weaken a known population before treatment with a mean of 80 and standard deviation of 20. After a treatment, we have an unknown population with supposed same variance and undifferent standard deviation. If the individuals in the sample are noticeably different from the individuals in the original population, we have evidence that the treatment has an effect. However, it is also possible that the difference between the sample and the population is simply sampling error. The purpose of the hypothesis test is to decide between two explanations. 1. The difference between the sample and the population can be explained by sampling error. There does not appear to be a treatment effect. 2. The difference between the sample and the population is too large to be explained by sampling error. There does appear to be a treatment effect. The null hypothesis, the alpha level, the critical region, and the test statistic. The following 4 steps outline the process of hypothesis testing and introduce some of the new terminology. Step 1. State the hypotheses and select an alpha level. The null hypothesis, H0, always states that the treatment has no effect, no change, no difference. According to the null hypothesis, the population mean after treatment is the same as it was before treatment. The alpha level establishes a criterion, or cutoff for making a decision about the null hypothesis. The alpha level also determines the risk of a type 1 error. Step 2. Locate the critical region. The critical region consists of outcomes that are very unlikely to occur if the null hypothesis is true. That is, the critical region is defined by sample means that are almost impossible to obtain if the treatment has no effect. The phrase almost impossible means that these samples have a probability, p, that is less than the alpha level. Step 3. Compute the test statistic. The test statistic, in this chapter a z-score, forms a ratio comparing the obtained difference between the sample mean and the hypothesized population mean versus the amount of difference we would expect without any treatment effect, the standard error. Step 4. A large value for the test statistic shows that the obtained mean difference is more than would be expected if there is no treatment effect. If it is large enough to be in the critical region, we conclude that the difference is significant or that the treatment has a significant effect. In this case, we reject the null hypothesis. If the mean difference is relatively small, then the test statistic will have a low value. In this case, we conclude that the evidence from the sample is not sufficient, and the decision is failed to reject the null hypothesis. Errors in hypothesis tests. Just because the sample mean, following treatment, is different from the original population mean does not necessarily indicate that the treatment has caused a change. You should recall that there usually is some discrepancy between a sample mean and the population mean simply as a result of sampling error. Because the hypothesis test relies on sample data, and because sample data are not completely reliable, there is always the risk that misleading data will cause the hypothesis test to reach a wrong conclusion. Two types of error are possible. Type 1 error. A type 1 error occurs when the sample data appear to show a treatment effect when, in fact, there is none. In this case, the researcher will reject the null hypothesis and falsely conclude that the treatment has an effect. Type 1 errors are caused by unusual, unrepresentative samples. Just by chance, the researcher selects an extreme sample with the result that the sample falls in the critical region even though the treatment has no effect. The hypothesis test is structured so that type 1 errors are very unlikely. Specifically, the probability of a type 1 error is equal to the alpha level. Type 2 errors. A type 2 error occurs when the sample does not appear to have been affected by the treatment when, in fact, the treatment does have an effect. In this case, the researcher will fail to reject the null hypothesis and falsely conclude that the treatment does not have an effect. Type 2 errors are commonly the result of a very small treatment effect. Although the treatment does have an effect, it is not large enough to show up in the research study. Directional tests. When a research study predicts a specific direction for the treatment effect, increase or decrease, it is possible to incorporate the directional prediction into the hypothesis test. The result is called a directional test or a one-tailed test. A directional test includes the directional prediction in the statement of the hypotheses and in the location of the critical region. For example, if the original population has a mean of 80 and the treatment is predicted to increase the scores, then the null hypothesis would state that after treatment, H0 mean is less than 80, there is no increase in this case. The entire critical region would be located in the right-hand tail of the distribution because large values for M would demonstrate that there is an increase and would tend to reject the null hypothesis. Measuring effect size. A hypothesis test evaluates the statistical significance of the results from a research study. That is, the test determines whether or not it is likely that the obtained sample mean occurred without any contribution from a treatment effect. The hypothesis test is influenced not only by the size of the treatment effect but also by the size of the sample. Thus, even a very small effect can be significant if it is observed in a very large sample. Because a significant effect does not necessarily mean a large effect, it is recommended that the hypothesis test be accompanied by a measure of the effect size. We use Cohen equals SD as a standardized measure of effect size. Much like a Z-score, Cohen equals SD measures the size of the mean difference in terms of the standard deviation. Power of a hypothesis test. The power of a hypothesis test is defined as the probability that the test will reject the null hypothesis when the treatment does have an effect. The power of a test depends on a variety of factors including the size of the treatment effect and the size of the sample. That's it for this video and we hope you find it useful. And if you haven't done so yet, don't hesitate to subscribe and activate the notification bell so you don't miss any of our upcoming videos. A like and sharing of this video will also make us happy and allow many other people to discover it while knowing that all the efforts we make allow you to improve on a daily basis on statistical models applied to the social sciences. On this we say see you very soon for a new video.